So, welcome to East Academia. My name is Brian, and today we are going to talk about chain rule differentiation. I saw it fit making this video before I introduce the L'Hopital's rule, because we are going to borrow some of these concepts in a method of evaluating limits through the L'Hopital's rule. Now, in chain rule, we usually introduce a new variable. So I will just write here a new variable, okay, to represent the innermost, to represent the innermost or the interiormost parts of a problem or of the problem, and reduce the problem in a form in which other rules of differentiation can apply, especially power rule, quotient rule, product rule, and so forth. Okay, so far we've only covered the power rule. So even the examples that I'm going to use here, they are going to actually be talking only about power rule. All right, so we'll reduce the problem into a form that power rule can do at can evaluate. Then later on, we are going to cover something on the product rule and the quotient rule. All right, so the best way to teach you or to show you this chain rule, I will just write its equation first, and I'll just write dy over dx. Okay, that derivative is written as dy over dp multiplied, or you can just put a bracket, dp over dx. All right, when I was in school, I usually thought of it like when you write it like this, it looks like this dp and dp can cancel and you remain dy dx, which is this. And it really helped me a lot. All right, it really helped me a lot, saying that this dp and dp will cancel and you remain with dy over dx. But in essence, you don't cancel anything. All right, just write it as it is. And remember, it can be for p, it can be p, it can be m, it can be whatever, as long as it's a new variable. All right, so the best way for me to show you this or an illustration is for me to do an example together. All right, so whatever letter you're going to take for this new variable really will define. If you use m, then this will be m and this will be m. So example, as an example, you are told to differentiate the following function: y is equal to x squared minus 6x minus 10 raised to power 20. Okay, solution. So when you look at this equation, you really can't solve it directly, as much as here we have power rules and all that. Remember, this entire function is enclosed into a power of 20. So it is easier for us to rewrite these equations and by saying let p be the innermost, okay, be the innermost, which is x squared minus 6x minus 10, all right, such that, so you can just draw a line such that y is equals to p raised to power 20. So in this place now we can easily differentiate, yeah, using power rule, right? So we are looking for dy over dx. So for us to get dy over dx, we have to get dy over dp and dp over dx. So dy over dp we can get from this equation. As you can see, y as a function of p. So dy over dp, if you use power rule, it's going to be what? Yeah, exactly. I think we've covered power rule. It's going to be 20p raised to power 19. Yeah, we've covered power rule, so it shouldn't be an issue. And then now dp over dx, what is it going to be? It's going to be 2x minus 6. All right. So then, because you are told dy over dx is equals to dy over dp multiplied by dp over dx, what it means is that you multiply these ones. So you are going to have 20p raised to 19 multiplied by 2x minus 6. At this point now, you come and substitute with the value of p. What is p? P is this. All right, p is this. So you write it out. So it's going to be 20 into x squared minus 6x minus 10 raised to power 19 into 2x minus 6. All right, so that is the solution, which of course you can write it in any fancy form. You can write it 20x minus 6 into x squared minus 6x minus 10 raised to power 19. So something of that kind, yeah? You can also write your solution in such a way. Yeah, all right. So next, that is the solution actually for this question. So next, I think I should just do an example before I give you guys an exercise. So we are going to have another example, then I'm going to give you an exercise concerning this chain rule. So I can just, so example 2. So example 2, you are told to find dy over dx given that y is equal to the square root of x squared minus 4. All right, some of you can just try it if you are bold enough, but this one is not an exercise. This one is an example. So we'll just solve it first with you before I give you the exercise. So solution, we can choose, because I said you can say whatever variable, the innermost the part of this function can be represented by whatever variable. All right, so I can say let m be x squared minus 4, isn't it, such that y is equals to the square root of m, isn't it? And the square root of a number, this one can be rewritten as m raised to 1 over 2, isn't it? So I can have a function, I can just have here y is equals to m raised to 1 over 2 and m is equals to x squared minus 4. All right, so then here I'm going to get dy over dm. When you drop a half, you're going to have a half, and then m, then you subtract 1. 1 minus a half, you're going to get minus 1 over 2. Okay, and then for this one, it is going to be dm over dx, which you're going to get the answer as 2x. So then dy over dx is going to be generally dy over dm multiplied by dm over dx, which this then is, what am I going to say? It's a half m raised to minus a half into 2x. So these 2 and 2 can cancel, yeah? So I'm going to remain with x m raised to a half. And what it means, I can write this m raised to a half and remove this negative sign here by taking it down. So it's going to be m a half, which is the same still. When you take the reciprocal, that negative sign disappears, okay? Which is the same as x square root m, which of course is the same as x over, after you substitute the value of m, we said m is x squared minus 4. So x squared minus 4 square root. So something of that kind. So this is that solution using chain rule. So be very keen, and also remember to substitute at the end. So then with what I've done here, then now I believe you are able to take an exercise, okay? But still remember, m raised by minus 3 is the same as 1 over m cubed, all right? So this minus means it's a reciprocal. All right, so let's have an exercise here so that you can try it out and see how you're doing. So find dy dx given that y is equals to the square root of 5 plus x. So you can pause this video, take your time to solve, and then we solve it together. Right, thank you for attempting. So we go ahead to check and see what you've had vis-a-vis the right answer, all right? So we can assume, so let m be 5 plus x such that y is equals to m raised by a half, isn't it? A half, this one is because of this square. So here we're going to have dm over dx. What are you going to have? We're going to have 1. And this one, dy over dm, we're going to have a half, m raised by minus a half, isn't it? Then you're going to say that dy over dx is equals to dm over dx multiplied by dy over dm, isn't it? And this generally is going to give us 1 multiplied by a half, m raised by minus a half. So as I said, this is going to be a half, 1 over m times m raised by a half, isn't it? Which, of course, this again can be rewritten as 1 over 2 square root m, which of course you replace the value of m. You're going to have 1 over 2 root m is 5 plus x. So basically this is it, and if you got this answer, then you are good to go with chain rule. So in the next video, we're going to talk about rules of differentiation before we can proceed to the L'Hopital's rule. No, let us proceed to the L'Hopital's rule first, and then we talk about the rules of differentiation. Yeah, before we talk about the rules of differentiation, let us cover the L'Hopital's rule. And for now, I believe if you're following this unit, I believe you are not yet lost. And if you're lost, be sure to reach out through my email, and I shall be able to assist you at eastacademia@gmail.com. So this is it concerning chain rule differentiation. So thank you for watching. Please share this video. Please like, subscribe, and hit the notification bell. And with that, thank you and have a nice time. See you in the next video.